Yes, sir. We are going live, sir. We can start.
Yeah.
Good morning, everyone. Thank you all for joining us in the live webinar for the second ever webinar in GAIMS Tamilnadu. So I know that you all will be excited as like me to know about the topic artificial intelligence in medicine. So you can ask all your questions in the comment section in the YouTube chat box. We will answer everything at the end of the session. To enlighten us in this topic, artificial intelligence in medicine, we have Professor Dr. Ganesan joining us here. We welcome you, sir. So to give a brief intro about him, he did his PhD in computational theoretical physics. Postdoctoral fellowship he did in applied mathematics for 3.5 years in at UK. So he has been an entrepreneur, he has been a professor, and also for the past 17 years he has been in the administration of VAT. So he has increased the placements, he has revamped the various courses and curriculums and got UGC approvals, and he has collaborated with various industrial people. He has contributed in various research projects, sponsored research projects. Also, he has filed various patents, and he has encouraged various people to file patents. And also, they are currently in use in Indian Railways and various other industries. And also, he has done various innovations. He has done various international collaborations. And also, he is helping a lot of people to start their own startups, achieve their goals and dreams, and also to get good jobs and placement. So, we welcome you, sir. So,
thank you, sir.
Over to you, sir.
Okay. Thank you all. First of all, I would like to thank the Global Association of India Medical Students, Tamilnadu, for giving me an opportunity to talk on how artificial intelligence can be applied in medicine. In a nutshell, I may be, talking on some of the some of the applications which we have been working with some of the doctors nearby. And then also we have come out with a few patents, and thanks to Corona, we were not able to capitalize in making it as a commercial product, but then we are on the way. So in the course of my presentation, I will also explain some of the basics and then some fundamentals if someone wants to work in the area of AI. In particular, like even if they have a problem in mind, they should know, what sort of problems can be solved in AI. So we need to have at least some basic knowledge of what is an AI. I will just touch upon, and then I will try to minimize as much of mathematics and engineering as possible, so that we can think of some new directions and maybe new applications. So let me, before going into the presentation, I would like to say that when we want to apply, artificial intelligence, we need a large amount of data with, different varieties and so on. So first one has to understand what are the various kinds of data that are available, and then, how I can leverage it for, for medical applications. For example, if you take presently, the doctors are broadly using three important kinds of data. So one is a plain text to data. Normally, if you are a doctor and then when a patient comes, you write a prescription in in English preferably, or in sometimes even the local languages and so on. And otherwise, you will also prescribing them to go for some lab testing, especially the clinical testing. When they undergo the clinical testing, again they give you a report in the form of text to data. So most of your subsequent treatment is highly dependent on these clinical data, which are essentially in text format. And the second variety is signals. And of course, we also use a lot of signals in the medical field. For example, your heartbeat, your ultrasound, ECG, EEG, and sometimes even people talk and observe from the way from their voice and speech. They are also finding out how much they are stressful and so on. So typically, the signals are a kind of data which can also give a lot of useful information about a patient. And of course, the third, which is emerging, is something called images. And different parts of the electromagnetic spectrum are now used while taking an image. For example, people are using X-ray, MRI, CT scan, and whatnot, PET scan, and so on. And also, people are using the live video camera feed, and to find from the gestures of the patient, they would also like to understand, their stress level and so on. We will talk a little bit with more details and so on. So images and of course now videos are coming in a big way, because typically in any of these medical treatment or any medical devices, what happens is, as a doctor, you all know that we may be using our common sense, namely, by looking at the temperature of a particular part of a body of a human being, or when he is coughing or when he is making a sound you hear, and then you are able to diagnose. Or sometimes you look at, for example, you look at the eyes, look at the nails, and say based on the color of the parts of a body, you are able to gauge or predict certain kind of diseases. So the human intelligence is primarily identifying or predicting a disease by maybe using the senses like touch, heat, sound, and maybe vision. So the same thing also we can teach it for a computer by means of artificial intelligence technique, and then we can ask the computer to make a decision just like a human being is making it. So from an artificial intelligence perspective, so what we need to know is, suppose if you are working in text, for example, my applications or text based application, so we need to understand something called natural language processing. I will talk briefly what do you mean by natural language processing and why do we need to do it for uh, like an AI application. Then if you are working with the signals, maybe we need to do something called a signal processing. A signal processing is typically like a time series data. For example, if some patient is admitted in the ICU, if you want to continuously monitor his heartbeat over a period of time, if it goes into any abnormal levels, so immediately you see that something is going to happen, so you want to treat the patients. So typically as a function of time, right, the heartbeat signals are continuously varying, so that I can capture it. Maybe in our x-axis I have time, and in the y-axis maybe some amplitude of a particular signal. So in the case of heart monitoring system, you want to see that how frequently the heartbeat is happening, that you want to record and so on. So it is equivalent to something called a time series analysis. And then if you are using images, and we normally call these as a computer vision nowadays. So what you do is, from an image which is taken from an X-ray or MRI or CT scan or PET scan with respect to a particular portion of your body, you want to see that what kind of interesting features you need to be there. For example, when we take an X-ray as a doctor, you will be under the lights, you will look at the images, and then you look for certain features, maybe certain characteristics in it. So the same thing also we can give it for an artificial intelligence system to do it automatically without even a human intervention. Okay, so the next we will see is what are the challenges we have. For example, if I want to take processing of a text, what kind of challenges we have. Of course, the text is in different formats. For example, it may be a plain text. When I say plain text means the one you type in Notepad or MS Word and so on. So the advantages of all these plain text are that when you digitize it, and then when you write a different application, assuming that one device is generating the data and then it is storing the diagnosis in a plain text format, but then if you want to pass it on to the other device, it should be able to understand. So two different devices, when they want to communicate, you need to communicate in general by using a plain text. So the interoperability across medical devices is possible if you store your text data in plain text format. The second is something called hypertext. So nowadays we are all using internet. Not only we want our application should be a standalone working with a particular device, but then you want to push the information into the cloud or into the internet, or from the internet you want to pull some data and so on. So when you want to make your application to be web enabled, what we need to do is we are bringing in something called a hypertext. So whenever there is a hypertext, you always there will be a link which may be looking at in the blue color by default. When you double click on it, it takes you to a different computer wherein you will get more information about the content that you are looking at. So normally now people are in the world of web application, they mix a plain text with the hypertext. That is second. And third thing is PDF text, and it captures all the elements of the printed document as an electronic format. It uses special softwares like Acrobat Reader and so on. So sometimes you want to use it for legal purposes or maybe for insurance purposes and so on. So you want to store in a special software so that it can be even printed, or sometime when it is printed, you want to have it be read by your computer software. So that's the place where we use a portable document format, which is also a text format, but it is more tuned towards a printed document. Then comes proprietary text. Here a file format of a company which contains the data stored according to a particular encoding scheme, such that the decoding and interpretation of the stored data is done only with a particular software or a hardware. So here the company which is making the software, they want to store the data in a particular format so that the person who is using that software alone can read it. So when I have a the vital data or my equipment is pretty expensive, always I want to use a proprietary text and so on. So it's not something very convenient for other application to read. And then there is something called, nowadays we use something called Unicode. So when I say Unicode, people want to write the data in different languages. For example, when we speak even in Tamil, in between we use English words, or even Hindi, we may be using English words and so on. So it's very difficult nowadays somebody to speak only in one particular language. So the same is true. The doctor with whom we are working here, and we being at Vellore, close to Andhra Pradesh, border of Andhra, he is getting a lot of people from Andhra, and moreover he is near to VIT where a lot of North Indian students are there. So typically I could see that when a patient is coming, he has to explain in his own native language, apart from English. The medicine name may be in English, but the way you will be using and so on. So if you really want to make him to understand or even to attract, you need to use multilingual language. So the same is true even when he writes in a prescription. I will show you a demo wherein he writes, he is asking what is your mother tongue. Accordingly, he is writing how medication he has to take up. So now we know that there are different kinds of text. Now let's see what challenges we have if you want to handle these text. For example, if whenever you write any text, we want to follow certain grammar. It may be in any language, but we have a grammar. But of course, this grammar is not standard for each language. So what is the grammar followed in English? It may be different in Hindi or maybe in Tamil and so on. So when you use multiple languages, first you need to understand any text message means what is the grammar they are following it. And then comes spelling of the words. And of course, many a time, the spelling also varies from country to country. For example, if you take, there are minor differences between British English versus US English. So maybe in Britain, they may write a COLOR, but in US, they may write a COLOUR or vice versa. So there are some, spelling issues are also there. Then there are issues of pronunciation. So when people, nowadays, we start dictating, and then there are speech to text softwares are there, which are, converting into a text format. Suppose if I'm going to show you a demo or a product where at the time of, doctor, when he is explaining to the patient how he has to take a medicine, he may be, using his own pronunciation. That pronunciation should be known to the patient as well. So now the issues are, for example, speech to text. As I mentioned, if I use college, you know that typically, a Keralite may pronounce as college. Maybe a Tamilian may be pronouncing it as college and so on. So it's the same spelling, but then people are, pronouncing it in a different way. But in the medical field, if you are a doctor, your pronunciation should not mislead to a patient. So we need to take care of these issues. Of course, there are vernacular words, and sometimes it is very difficult to find these words in a dictionary. For example, we say that bothering. If you look at the word bothering is typically used by Indians, or we use the words like, jugad and so on. So when you are, the way you are speaking, if you are started using these words, so even if it is given to your computer, as it is not in the dictionary, it may be finding it difficult to understand what it is. So then comes, sentiment analysis. And here we are also going to use words according to the mood. So the same person, when he is happy, he may be using certain words, but when he is very angry, he may be using, some other words. It may mean the same, but the way when you talk to a patient, even the words that you use, right, it is going to make a lot of difference, especially, if you want to convince a patient, or if you want to attract a patient, the kind of words that we use also will make a difference. So when you say something at the end, we need to say that is these words are in a positive sense or maybe in a negative sense, which is going to make a lot of difference for a patient. Then comes vocabulary, and again a set of words are used by a person, which again varies from one individual to another individual. So it's again, people say that a typical human being, even though there are about 2 lakh words are there in a dictionary, they always use maybe some 5,000, 6,000 words in our day-to-day life. So instead of creating a dictionary or a vocabulary for all 2 lakh words which is there in the in the typical encyclopedia or dictionary, if you are making a custom made dictionary which is meant for the kind of words that you are going to use, what is going to happen is the storage that you use, or the response of our system, and even the accuracy of your artificial intelligence model that we are going to build will be better than using a general a dictionary. And then comes image text. When we talk of image text, one can read the image text using optical character recognition and so on. For example, if I take a medicine or a pill or a tablet, they have printed some text, and they may be in different color, different fonts, and different size and so on. So if I take a snapshot of that image and then I ask my system to tell what is written on it, so many a time you see that people may be using a lens and then they may be reading what is there and so on. So instead, nowadays, we have a camera in our mobile phone. So can I take a snapshot of it and then ask, what is the, let us say, the composition of the medicine, or maybe what is the date of expiry, or which company has manufactured. So all those information I can ask the artificial intelligence system to read. So in that case, the we use a technique which is called optical character recognition. So the text can be present inside an image, and again AI can be used here and to read the text. Then when we say optical character recognition or optical character reader, it's an electronic or mechanical conversion of images of typed, handwritten, or printed text into a machine encoded text, whether from a scanned document or a photo of a document or a scene photo, or from a subtitled text superimposed on an image. So typically what I'm talking is some printed document is there. It can be a photo, or it can be a snapshot taken in your mobile phone. And so whatever the script it is written by hand or printed, it is basically, when you take it, becomes an image, like a graph, a graphics. So from there I cannot read it. So we need to have an intelligent system which is going to convert that image file into a text file. That's what your optical character recognition, or OCR, is doing it. And then comes, each language has got a different font. So the problem here is, now we see I have mentioned something Algerian, curl, ML, and then something called Kunster script, etc. and so on. So all of them are written in English, some alphabet, and it refers to some name, right? But then when you print it, it looks with a different look and feel. So when somebody writes, we may see that he may also write in different styles and fashion. So how do we ensure that our artificial intelligence is able to understand? I'm not talking about handwritten fonts. Even the printed fonts itself have got different variants of there. So no matter whichever variant you have printed, your the tablet or on the medicine, I should be in a position to read it. So if the letters in the document are cursive, then machine learning algorithms are used to recognize. So later on, I will show you, that if something rightly, these curly signatures or prints are there, so we may not able to use the conventional image processing technique, but rather now people use something called a machine learning algorithm, which is even able to recognize, what that you have used or written. For complex handwriting recognition, we are using, deep learning based OCR. And for example, you take, this is with one of the doctors nearby with whom we are working. So he is a pediatrician, right? And then he has got such a complex, format. You see here he has written in English, in Tamil, and then he scribbles something. Of course, a trained pharmacist, he may be able to read what he has written it. But then now I want to see that can I use an artificial intelligence engine to tell what he has written. So this is something like he has written, and then using what we call as deep learning technique, my system is able to tell the name of the medicine is Renoclear, and then it is a drop type. Because the issue here we are going to see is it is with a pediatrician, because a pediatrician is using different varieties of medicine. Maybe at the early stage he may be using drop, then he may suggest like syrup, then he may say suspension, then he may say tablet, and then rarely he may be even using different doses of the tablet depending on the age of a kid or a child. And then later he may be also using a capsule. So the difficult thing is the same brand or the medicine may be coming in different formats. It is not only the name, but then you need to see that in which format he has written it. So we just want to build an AI system which is basically reading your text, which is as complicated as this, and then extract all sorts of information. So for doing this, what we need to use is something called natural language processing. So what is natural language processing? The goal of natural language processing is to enable the computer to understand language as we do. Just like a human being is able to understand any language like English, Tamil, Hindi, we also want a computer to understand a given language. So it's used in many virtual assistant speech recognition system, sentiment analysis, automatic sex recognition, machine translation, and so on. So in the last 20 years, huge amount of research has gone into, and there are many applications which have come out. For example, some of the classic applications of NLP are voice assistants like Alexa and Siri, and also things like machine translation and text filtering. So when you use Cortana, or when you use Google Voice, or like Amazon Alexa, or like Apple Siri, all they are basically using, when you say something, it is immediately understanding, and then your voice is converted into a text thanks to the natural language processing techniques. And the other area is speech recognition, the translation of spoken language into text. So this is again very very important. Sometime my voice may even change due to cold, or maybe like if I am sneezing, right? My voice will look like slightly different. But then your system should not recognize it as a different text. It should translate it into the right text. So when we talk here in the natural language processing, there are two important tasks. One is called syntactic analysis, and the other is called semantic analysis. And of course, these are the two main techniques which are used in natural language processing. When I say the syntax, it refers to the grammatical structure of this text. When I say something, like my name is Ganesan, I will see whether it is syntactically, correct or not. As per the grammar of the given language, I will see whether it is right or not. So when you return it properly, if the other fellow also knows not only the language, and if he also knows the grammar, then he will easily understand. And then the second term is called semantic, which refers to the meaning that it is conveying it. So you may say something. It may be all the words which are there in the English dictionary, but then if you stitch them together, it should convey some meaning. Otherwise, what is going to happen is he may not be able to understand. So a sentence that is syntactically correct does not have to be semantically correct. For example, I say a sentence, cows flow supremely. If you look at these words, cows, flow, and supremely, all of them may be in the dictionary. So I take them and then I stitch them together. And when you case something, like people will say, is this fellow is a mad fellow. How can a cow will flow? And that too, he say, it is flowing with the supremely, and so on. So if you look at all these words are grammatically correct, because we have a subject, we have a verb, we have an adverb. So, but it is not making any sense. So we need to see that when any like a text which is given to a computer, it has to parse it and see whether it is first conveying a meaningful grammatically. First, you can see it is grammatically correct, and then you see whether it is meaningful or not. And you take the other example. For example, if you say something, grammatically correct, again, colorless green idea, sleep furiously. Here, grammatically correct, but it is having no meaning because ideas cannot be green. When you talk some idea, if you say green idea, again, when you say green, it is a color. How can you say colorless? And then you say sleep. Okay, it's a verb, but you say furiously. When you say you are sleeping, you can say I am sleeping deeply or happily or restlessly and so on. But you can't say that. When you are furious, you cannot sleep. So all these words are grammatically you can stitch them together, but then syntactically we need to see that whether it is making sense or not. Okay. Now, so for all this, the fundamental thing we need to understand is any text, if you want to apply natural language processing or AI, is you need to do something called parsing. So parsing means an analysis of a sentence by a computer into its constituents, which results in a parse tree, which will show their syntactic relation to each other in a visual form, which can be used for further processing. So the most fundamental natural language processing starts with parsing. So when I say parsing means if you are giving a sentence, I will remove them into a set of words, and then I will ask what these words to refer to according to your grammar. And then like which is subject, which is object, which is verb, which is noun, and so on. And then I will find out what kind of relationship they have. So once if I am able to parse and then identify a relationship, then I can say that whether the sentence that you have spoken is semantically correct or not. So for example, you take the sentence, the thief or burglar robbed the apartment. Here, along with the description of the three different information types, so I can identify the noun, which is namely thief or burglar, and verb means robbing, and a determiner is the apartment. So a word or a group of words that specifies, identifies, or quantifies the noun or noun phrase which follows it is conveyed by it. So typically, my what you call parsing has to create this analysis. Here, the determiner can be an article or cardinal number or ordinal number, or it can be anything. For example, you see here, the sentence I have given is the thief robbed the apartment. So what a computer does is when we apply the natural language processing, it is seeing that the is a determiner, and then it can be, it is a thief or robber is a noun. Again, if it is robbed is a verb. Again, the apartment is a noun. So what it does is, it is attaching a noun with a determiner, and then it is attaching with a verb, which in turn is connected with, your NP. Here I call this as NP and VP. NP means noun phrase and verb phrase, because the thief is one phrase which is related to a noun. So I call it as noun phrase. And then robbed the apartment, which is a verb phrase, because it's a phrase related to a verb. So now I take this noun and verb and then I create a sentence. So if you create a typical sentence, I'm decomposing it into a noun and verb phrase. And then in the noun phrase, I look for the noun and determiner. And in the verb phrase, again, I look for a verb and the, again, is there is a verb phrase or a noun phrase. If it is noun phrase, once again, I decompose it. So typically what I get is here, how they are, related. So once we are able to do this, then it is easy for your computer algorithm to understand whether you are talking something meaningful or not. Then the second issue you may be very frequently using is called stemming. It's a process of reducing words to their word stem. Means a stem is part of a word which remains even after removal of all its affixes. It's as simple as assuming that if you are learning a new language for the first time, and then when you start using it, you may be using lot of grammatical mistakes. For example, we have been taught when you use third person singular simple present tense, you need to add a yes along with the verbs. He walks on the lawn. So here he is the third person and singular, and then walk is the verb. But then if it is a present simple present tense, we have been told that we need to add yes. Suppose if it is past tense, we need to add ed. And then if it is present continuous, we may be adding, ing and so on. So basically the stem word is touch. But on top of it, we add the cosmetics like ed or ing or yes, depending upon the grammar that you are talking. Now imagine that if some Chinese or some other language person is coming and then he is speaking to you, you may know that he is not using proper grammar. But then if you use a relevant word, right, you will able to understand what he is, for conveying. So typically in a computer also, we treat it like some foreigner is speaking, and then when you use multiple formers of the same word, we are only considering the base word or what we call stem word. And this process of removing these things like ed, ing, yes, etc. are called stemming process. So why do we need to do this? The stem is needed because we are going to encounter different variations of words that have the same stem and the same meaning in our conversation. So in our conversation, even if somebody says he walk on the lawn, we are not going to find of course we can understand that he is not speaking proper English, but then you will understand that what he is trying to convey. So for conveying, right, or what we call understanding, whether he is talking something which is relevant, even we can remove these words. So for example, you say, I was taking a ride in the car. I was riding in the car. Both are conveying the same message. So these two sentences mean the same thing, and the use of the word is, identical. So this is what we are doing it. Later, when we call something called, chatbot, right? We also use the same technique. The same message may be conveyed by different people using the vocabulary and grammar of a given language. So all we need to do is, in the case of an artificial intelligence, look to my computer, all these refers to the same context. So for that, the stemming is very, very, essential. So once if you know these two are stemmed, you will get the same sentence. Then comes text segmentation. Here, it is also a process of transforming this text into meaningful units, which can be word, sentence, or a different topic, and so on. So once if a sentence is given, we will break them, or if a topic is given, we will split them into paragraph, and each paragraph into sentence, sentence into word. And then we will see whether these words are there or not. For example, it works relatively well in English to separate the words by spaces, except for a few words like icebox, where I may be using a dash. So in most of the cases, it is very easy, because we need to. This is what I call as parsing, right? Segmenting your text into a smallest units, and then see what is the meaning of it, and then you start stemming, and then also you ask what parts of speech it belongs to. So if you want to do all this, first step is segmenting your text. Then we use something called named entity recognition, which concentrates on determining which items in a text or named entities can be located and classified into a predefined category. So typically what a computer or your natural language processing algorithm does is they categorize, or what they do is classify. For example, uh, the names of a person, it identifies where is the name of a person or name of a company, or if it is some value, what is the value of that money, or if there are some percentage, what is that, and so on. For example, if we take, if I say Martin bought 300 shares of SAP in 2016, here the noun or what we call person is Martin, and then bought 300 shares is of SAP is a company or organization, or in 2000 time 16 is the time. So it identifies the important things. If you know that one person has bought some shares in which year and so on. So once if you have the basic information, if you are extracted, then finding the relationship between them is little easier. And how do I find the relation? With
Sir,
yes.
sorry for the interruption. Your
Yes.
voice is like quite less audible.
Okay. Sorry. Is it audible now?
Yes, sir. Yes, sir. Sure.
Fine.
Thank you.
So now we need to say the last part is how do I find the relationship? It takes the named entities and identifies semantic relationship between them. So once if you are given a sentence, we need to see that what kind of relationship they have. For example, finding out who is married to whom, that a person works for a specific company and so on. So here you look at Fred and Mary got married. Now Fred is a noun, Mary is also a noun, got and married are verb, and is a conjunction. So once if you are able to identify, break the sentence into words and then link it to the vocabulary or maybe what we call as the grammar of a given language, then it is easy to connect them. problem in transformed is now transformed into a classification problem where we train a machine learning model for every relationship type. For example, I can have a database where I can say that if the name is Fred means it is the name of a person, Mary name of a person, and then all the verbs I can store it in a database like get, got, and then marry, married. All these are verb. So the whole problem is now splitting the given sentence into words, and then you classify the words into what kind of grammar they belong. After that, you know that if there is a subject, there should be an also a verb, and then also maybe things like conjunction is there, more than one verb is there. All these we can add into our algorithm. Then people also, as I mentioned, we use sentiment analysis. Here we determine the attitude of a speaker or a person or a writer with respect to your document or interaction or an event. So many a time, the doctor will also, when he is talking to a patient, so he is more, looking at his sentiment. Accordingly, he treats him, right? Whether he is, responding him, or whether he is, recommending something, he always uses sentiment analysis. So some of the sentimental categories are positive, negative, neutral, and so on. So a doctor's advice to a patient about medication in general follows this sentimental analysis. Predict, for example, a customer's opinion and attitude about a product based on a review he wrote about it, and so on. So these are some general examples. Now the next level, when you go for AI, where in the medicine field people are using, they are trying to use something called chatbots or conversational AI. We have also, maybe later I will show you in the final demo if possible, we are also using this conversational AI when a doctor is discussing with a patient. So what is this? A typical chatbot is an application of an artificial intelligence that we can interact with either by our voice or text. So typically it is like what you use in Google Home or Amazon and so on. But then we want to do it, we don't want to take your data to the Amazon or maybe your Google Cloud and so on. So can I create a custom made chatbot between the doctor and the patients whom he is treating? And typically this is a device with an audio and maybe there will be a speaker system. So it can ask as if I'm sitting in front of a doctor, assuming that there is the doctor is not there, and so he is coming and then sitting in front, and then as if there is a doctor is sitting, he is asking the questions. So the AI or chatbot will respond to him. So it can be, interaction can be through voice or it can be a text. Suppose if we are looking for a medicine on a pharmacy websites, we can search and then purchase it. Suppose if you have a huge database, even when we met some of the automation, we went to the pharmacy. They said we have around 9,000 to 10,000 medicine typically in a small medical shop. So when I go and say some particular medicine, so immediately that fellow has to understand, or you need to write and so on. So imagine that I have a kiosk wherein I just go and tell what medicine I want. So instead of telling and then waiting in the queue, and then the pharmacy wala calling what do you want, and then he goes and types into his computer ultimately saying, sir, it is not available in the stock, can you come afterwards? So instead, can I imagine there is a kiosk where I will just go and type or tell, I want this medicine, do you have with you? So it can immediately say yes, you have a medicine, or it can say that no, I have an alternative medicine. I may say I may want Calpol, but you may say I may give you something like Metacin or something. Equivalently, it can do. So those kind of intelligence systems can also be built. In fact, we are also now working with the doctor where when he writes something, before writing it, he wants to ask the chatbot whether this is available there in their pharmacy or not. So instead of writing something which is not there in the pharmacy, he will simply ask, is this medicine is there? So the chatbot will say, yes, it is there, sir, please you prescribe it. So he can even write on it. So what if that pharmacy makes a bot and sets it up on Facebook Messenger so that we can message it or tell it what we are looking for, and it will provide the option. So this is what we said. I can tell what I want, and then it can give me a recommendation. Based on that, I can choose what is available in stock in my shop or my pharmacy. So conversational or artificial intelligence refers to the technologies like chatbots or voice assistants which users can talk to. So they use large volumes of data, machine learning, and natural language processing to imitate the human interaction, recognizing speech and text inputs, and translating their meaning across various languages. So, in a nutshell, what this chatbot can do is it can be even in a multiple language. So the patient may say everything in Tamil or even in Hindi or Telugu, but then the database may be in English. It can convert and then understand, and then it can respond even in the voice of a doctor. Or I can even record the voice of a doctor, and then I can play whenever it is needed. So maybe before I'm keep on using the word what is called machine learning. Machine learning. I'll just introduce you what do you mean by machine learning. Machine learning is the study of computer algorithms which will improve automatically through experience. So typically what is this machine learning? Because you know that any learning, whether it is dancing, singing, or even if you want to have swimming, what happens is you need to take a lot of practice, and then even when you take a lot of practice, not only in one platform. For example, if I want to learn driving, if I drive only in highway where the roads are pakka, and then you can nicely overtake and so on, you are all right. But then suddenly if you go into a place where the roads are very narrow with a lot of potholes, and like people are crisscrossing and so on, so you'll be becoming very nervous. So you'll become a competent driver unless you are trained not only with a large varieties of data, but then also with a huge amount of data. So in the typical machine learning, what we do is we are teaching the computer algorithm all our experiences. So people generally say this machine learning algorithm is a part of artificial intelligence. So here we build a model which is based on the sample data known as a training data, and we make predictions or decisions without being explicitly programmed to it and so on. So how this machine learning is different is, normally if you look at people use some sort of programming language like C, Java, Python, and so on, wherein when you state your problem is translated into a set of programming instructions. So the data flows through, and then it gets an output out of it. So it is highly dependent on what is the logic or what is the program that you have written, right? So that is the flow it is doing it. Whereas here, in the case of machine learning, what happens is it is more of training based. When I say training based, I give lot of samples, and also all these samples have got a variety in it. So machine learning algorithms are used in a wide variety of applications like email filtering, computer vision, where it is difficult or infeasible to develop conventional algorithms to perform the needed task. So where I'm going to use, we will see. For example, ML is used for disease identification. So once if we give a MRI or a CT scan or something like, even if the radiologist is not there, no, I can say what kind of disease can I predict it. Just like in the ECG, when you take a report, the algorithm is saying where the defect is there, in which low PQRS we have defect and so on. Something very similar, we can do it. ML based image analysis, they are 1,000 times faster than the humans. The advantage of here is that in many cases we have seen, or literature is saying that compared to a human being, the machine learning algorithm can detect diseases very fast. And people are using AI powered robotic surgery. It is reducing the pains, they say up to 21%. So now people are using the robots for surgery, painless surgery, or they say less pain. And then people are also creating something called virtual nurses, which is taking 24/7 on patient care. And ML is used mainly in diagnosis and prognosis to drug development and epidemiology and so on. So you name any field now, it is coming up in a big way. And I may show you a simple example how the ML is working. But of course, we can even change this example for a medical application very easily. So one of the technique which is used is called naive. It's a simple machine learning algorithm, and it assumes that all the variables in the data set are not correlated to each other. So this is something like a drawback of this. But then people have also devised a lot of other technique. But here we assume that whatever we have a data, and it doesn't one when you do something, it is not going to affect the other. For example, which is not true. If I study well, probably I may do very well in the examination. So that means doing well in the examination is related to studying well. But then what Bayes is saying is that kind of connections it is not considering, right? So whatever you do is, it is assuming that everything is fresh. It has got no connection for the prior data. So we are walking on the playground, and assuming that a simple case, you are walking on a playground and you are seeing a red object. The red object can be a bat, or it can be a cat, or it can be a ball, assuming that these three possibilities are there. Of course, you know that there cannot be a red cat, but for argument's sake, we take different kind of objects are possible. Basically, when you see something on the road, you want to classify what it is. Let's create a machine and give the task of classifying it's an object in between cat, ball, and a cat. So I'm writing a small algorithm where I'm telling you, tell me whether it is a cat or ball or bat. For this, the machine has to identify the characteristics of the object and then map it with our classification objects, such that if an object is a circle, so essentially what you should do is you just take a photograph of that object, and then you analyze it using your computer algorithm. If it is circular in shape, definitely you will say it is a ball. It is not going to be a bat, or it is going to be a cat. And similarly, if it is going to be a living object, if we say, you can immediately say it is a cat. Or if there is a handle and then some rectangular shape and so on, so you may say it is a bat and so on. So that means even though there are three objects, all three have got some unique features or characteristics. So you need to write an algorithm which can capture these features and then quantify it, and then that is what I call it as a model. We can classify an object by mapping its features with our classifiers. See, so this is the simple formula I'm going to use, and don't get afraid of this formula. So this formula is simply is going to tell some probability. So you know that the probability means, for example, when you toss a coin, right? You know that the probability of getting a head, even before tossing, you will say is 1/2, because there are two options. It can be either head or tail, but then after doing the incident, you are going to get either head or tail. So that means what is the probability of occurrence of an event? You will just take this ratio of two numbers. So here, and I use a bar when I say P of C bar X means, where C means to which class it is belonging to. I will show you an example, you will understand. And X means uh, what features you are looking at, right? So here, cat, bat, and maybe the ball are all called category. And features are, I say, circular shape, rectangular shape, living object. All these are called the features. So if you want to know what is the probability of a feature, I mean probability of a class given the feature, you will be using this formula. It was invented by a person called Bayes. So let me now go into the details. Assuming that I will take a simple example, I will give you 1,000 pieces of fruit, right? Out of which 500 are banana, 300 are orange, and 200 are some other fruit. So now the fruit being a banana or orange or some other fruit, and imagine we know three features of each fruit. So now I see that there are three classes. Banana is one class, orange is another class, and other fruits are another class. So how many of them? 500 bananas in my basket, 300 on orange, and 200 are other. So totally I have 1,000. And then when I take any one of these fruit out of these 500, I look at some feature. So the feature is, am I asking it is long, or is it sweet, or it is yellow in color? So if you say yes, then I count it, and then that numbers are these. And similarly, I take orange, I ask these three questions. So what you see on the what we call the columns, like long, sweet, yellow are features, and in the rows what you see are classes. So typically when you have any data, you can map it into this table, and then you count how many of them. That's what this Bayes is doing. So here I am calculating the fraction. For example, 50% of the fruits are bananas. Out of 1,000, 500 are banana, 30% are orange, 20% are other fruits. Similarly, based on the data that I have got in the table, right, I am telling out of 500 bananas, 400 are long, means 0.8% is the probability. 400 divided by 500. And similarly, 350 are sweet, means probability is 0.7. And 450 are yellow, means 0.9. Similarly, you do it for orange and do it for remaining fruit and so on. So just to do a, once if you have all the data, you you create this table, right, where your rows are your classes and columns are your features, and then you take these numbers. After that, you calculate this percentage, all these values. Once if you have there, then I am simply going to use this formula. This is a formula which I was telling, the probability of conditional probability of a class over the feature x is given by the conditional probability of feature over the class, and what is the probability of class and what is the probability of features. So it's very simple. All you look at is this formula. First I say that I want to know whether, so you take a new fruit and then you are asking, is it a banana or not? So in that case, I say that what is the probability for a banana? It can have the features. C means banana, X here, or it can be long, sweet, and yellow. Now we see here in the table, this is P of C, and the other features are P of X, C of X. So I am sorting. So in that case, in the right hand side, I write the reverse of it. I take what is the probability of a banana being long, probability of banana being sweet, probability of banana being yellow, and multiply what is in the total number of probability of a banana. So all these values I have already calculated here. I'm just substituting, and then I get a probability of 0.252. Similarly, I do it for orange and I do it for any other fruit. So what is the machine learning algorithm is doing is, when I have taken 1,000 such samples and then using my images, if I have got all these features, it is saying that whichever has got the highest probability, I can predict that as the fruit. So that means if the fruit that you have chosen happens to be long, and also it is sweet, and also it is yellow, then we can say that it is a banana, because based on the data that you have got, you got this number. So the beauty here is that when you add, instead of 1,000, if I have got some 10,000 values, so what will happen is, it may so happen that the value that you get here may be also very different. With more and more data, what is going to happen is the accuracy of your prediction is very high. Yes, sorry.
Sir, again the voice is less.
Yeah. Sorry. Is it audible now? Yeah. So now we can imagine that the scenario which I am going to tell you is that if you are a doctor, what happens is, that in the case of a medical application for a given disease, we may have many symptoms. You take one particular disease, like a viral fever, you may have a number of symptoms, maybe a sore throat or coughing or body temperature. So all those are features. So you take various medicine, say various diseases, and then for a given disease, and then you take another disease, it may be like vomiting. So what are the symptoms or features you will look at in the case of like a vomiting? So on one side you have various diseases, on the other side you have got various symptoms are there. So now what you happens is, for every patient, right, you might have diagnosed after going through it, and he has reported all these things. These are the features. You may be asking, are you feeling vomiting, or you may asking, are you feeling cough, and so on. So you are going to ask this data. So those are the features, and then you may be arriving at, as a human being, that it is maybe a viral fever. But it may so happen that it is not that the same data, when I give it to two different doctors, they give you a different interpretation. So it may so happen that if you take a large number of patients and then give it to all these features, and then ask the doctor, how do you predict what kind of disease he is? So it is going to vary person to person. So when you do a lot of such analysis, you are going to get a table like this. So once if you got a table, then you can do a simple like ratio calculation. You will be arriving at this kind of the naive-Bayes formula. So once if it is, then what happens is, now imagine that when you are not there, and I have a huge database which has been created by interacting with a large number of patients with respect to a large number of doctors. So I take you 100 prescription and then say, these are the symptoms. So how do you diagnose, doctor, or what disease you predict? I note it down. Similarly, I go to the other doctor and then I calculate all these things. So then what happens is, imagine that once if this algorithm is built, and then a new patient is coming and no doctor is there, only a nurse or somebody is there, and then he is telling, so these are my symptoms. Can you predict what kind of diseases? So immediately saying, using the about technique, what kind of disease you are suffering from, and so on. So this is something like the simple text-based data that you take using machine learning, we can bring in, intelligence. As I mentioned, when you have more varieties, you use more features, or when you discuss with more doctors, the accuracy of your prediction is going to be improving day by day. We cannot say it is 100% correct. Just like as I mentioned, the same report, when I give it to multiple doctors, each is predicting in a different way, slightly different way. Okay. And maybe for want of time, I may just rush through a few more things. So what we have also done is, there are few applications which are based on audio, right? uh, so one of the application is, we worked with a leading diabetic hospital in Chennai, and this doctor was telling, he used to go to a lot of schools, especially in Chennai, which are like private schools, where he found that even in the 7th or 8th standard level, the students have got lot of obesity, and then he want to do their eye testing, and then he want to, because we know that one of the implications of obesity or subsequent diabetes is, it is also going to affect your eyes. So they wanted to do an eye testing. So typically, we will keep a Snellen chart and ask a patient to stay at 15 feet distance, and ask them to read line by line from top to bottom and so on. But then this doctor was telling that when we went there, and we know that, this fellow had a vision problem, when even the teachers and parents were complaining. But then when we did the testing, there was no such, implication. Of late, they came to realize that what happened is, the children, we know, they are all always, when somebody is asking, we parents are always telling that, if you say I don't know, or I'm not able to read something, we will feel that as if offended. That's how we are training them. So what these kids were doing is, when the first kid is going, that this Snellen chart is a fixed one in every like eye doctor or ophthalmology. We see that the same chart is being used. So when a student is coming, first student, he will mug up the sequence of the words like F, B, C, R, and O, N, B, R, X, and so on. He will tell to the next friend. So the second student, when he comes, without even knowing, because all these are fixed Snellen chart, he will also repeat the same thing. As a result, they were not able to diagnose whether he has really got some vision problem or not. So he came to us and then said, sir, can we solve this problem? I said, I can use some voice recognition system along with text processing. I can do it. So what we typically did was, we created this channel chart, which is a static one in a conventional ophthalmology testing. We made it as a randomized text. So what you see here, for the first student it may be F, maybe for the second student it may be Z, and then third student it may be O, and so on. So for every student, what we did was, we randomized this text. So when a student knows that what is being displayed on the Snellen chart is different for each, they were not mugging up and then telling the same thing. And then whenever he was reading every row, we made an audio recording, and then with the chart that has been we know that this is the chart, right, where F is there. So I made a translation of text to speech, and then whatever the student was speaking, I did an audio pattern matching. Based on that, I was able to tell whether the first character, what was randomized and displayed, and what is the student has pronounced, whether they are matching it or not, and so on. So this way, we were able to solve this problem. So the same thing also we did, and here it was meant for color blindness. So when a student has got some color blindness, we use these palettes, and then we ask them to read what is the character inside. So again, we know what is the character inside, and then we converted into a speech, and then asked the student to read what is the character inside this palette. And when there was a matching, we were able to know that he doesn't have a color blindness. But when then he was reading in a different font or a different alphabet, we know that he has got a color blindness. So we can do a simple automated color blindness testing. And also the kids were very happy, because we put some chart in front and asked them, give a headphone, and then there is a mic, and then in a computer we were recording, and then some audio message for them to do, like a fun they were playing, and then they enjoyed it and so on. So we found that this testing was very effective than we conventionally do with a set of people going and then displaying a standard chart and so on. So maybe in the next few minutes, I will talk on deep learning. Deep learning is a subset of machine learning, which on the other hand is also a subset of artificial intelligence. So what is the difference between deep learning and machine learning? Uh, Typically in the case of machine learning, what happens is a set of algorithms are trained to make the data. What we do is, like the example which I have given, right? So when there is a medical report or diagnosis is there, right? Symptoms are there, and then the doctor was able to tell what disease and so on. So that means some human being has to decode. So this is cough, temperature high, maybe coughing less, or all these symptoms are to be manually, the text data need to be understood, and then the feature need to be extracted. But in the case of deep learning, what we do is we use something called a neural network, so which is basically a set of neurons which in your brain is getting connected and trying to remember things and make decisions and so on. So we mimic these, and in computer algorithm call it as neural network. So we use a huge number of neural network in different layers, and then we give a lot of example, and then we ask the neural network, I will do nothing, I will keep quiet, you learn everything by yourself. So the main difference in the machine learning is in the initial stage, a human is involved in identifying the features, or what we call feature extraction. Okay. The machine learning algorithms are called flat algorithms because the algorithm cannot normally be applied directly on the raw data. So if you take some X-ray image and simply give it to a machine learning algorithm, it can't do anything. So what we need to do is we need to do a pre-processing, which we call as extract the feature, where to focus, and what kind of features to look at, how much I need to look at. All these we need to, sorry, do it manually. But then in the case of deep learning, what we do is even that is done by automatic means. So I give simply the data, and then the system will learn everything on its own. So this is in a nutshell the major difference. For example, I give me an image of a car, and then a human being is sitting. How do I know whether it is a car? I need to tell that it has got two wheels, it has got a steering, or it has got a headlight. All those are, I am classifying it and then feeding this data, and then I am training it. Not only with one car, I will give hundreds of car, and then say, this is how the headlight, or this is the place where headlight is there, and so on. And then finally I will say whether when a given image is a car or not car. So this human intervention is there in the machine learning. But in the case of a deep learning, what happens is there is no human intervention. So everything is automated, right? And then the output is obtained. Okay. Maybe I will just explain something which we have done. And so what we have done is something we have built using artificial intelligence called a medicine identification system. So in many hospitals or nursing homes, we know that there is a pharmacy, and the patients are generally buying the medicine which is prescribed by the doctor, especially in private hospitals. But occasionally the pharmacists are making mistake in decoding the prescription. So maybe he will read only few things, or if he is not an expert, sometimes he misunderstands it. So sometimes they give you a wrong medicine, wrong type of medicine. As I shown, doctor might have given drop, but he may be giving a suspension, or vice versa. And at times they deliver wrong dosage also. He might have given 500 milligram, but he may be giving 650 as well. And sometimes he may also give an alternative medicine. So many a time we will, if you are educated, we will take it to the doctor and then say, sir, in the pharmacy, this is not there. He is saying it is inequivalent. Can I take it or not? So without the approval of a doctor, we don't want to take it. So all these calls for the time for the patient as well as for the doctor who is doing, instead of that, this simple work, he can spend his valuable time on meeting more patients. So what we have built is an AI-based system which can validate the medicine given by the pharmacist with the prescription and alert the patient if there are changes and play the medication instruction in the vernacular voice of the doctor. So typically what we have built is we have built a device. So in this particular device, what we need to do is, simply, you put this prescription. So here I see that, this is the prescription designed by the doctor. And this device has got some lighting systems and cameras. And what it will do is the moment you put the prescription in, it is like, you can imagine like your printer. Just you feed the prescription sheet. So this device will switch on the camera, and then the lights, and then it will read what is there, right? And then it will know that rinocular drops. So he knows that the name of the medicine is rinocular, the type is, drops. So then it can also read other things, like, he has written hours once, right? Or money, neram, vorumani, something he has written in this language. I can even train all these things. It can capture whatever the doctor has written in multiple languages, and then it can store it as a text format or understand is a standard text format. After that, what it has to do is it has to, you know, it has got a, chamber. You can open the chamber, and then you can put the drops, maybe, the medicine, whatever medicine it is given. So if it is a bottle, right, you know that the name of the medicine should face the camera. But then, we have made a system in such a way that even if you remove the label, or if the label is partially occluded, not visible, even the camera is able to see a part of it. It can clearly tell the medicine that you have put in the chamber is a rinocular, and also it is of drop type. So when these two are, matching, immediately you may get a green light. So I will know that whatever the doctor has written by hand is what is given by the pharmacist. So there is no error in it. Suppose if it is showing an yellow color, I will know that the doctor has given something, but the pharmacy is saying that this is also equivalent. So, but then instead of going into the doctor, if the doctor has already set the equivalence database, so then when it is green, it may play a message in the name of a doctor's voice that the medicine that you have been given is also equivalent to what you are supposed to take. Suppose if we get a red color, then we know that the pharmacy fellow has given a wrong medicine. So it can even identify syrup or drop or suspension. We have done for about 150 pediatric medicine which was there in their hospital. For all 50 cases, 150 cases, the accuracy was more than 99%. I can't say it is 100%, but it is more than 99%. And then comes even tablet. So the problem with the tablet is that most of the time what happens is you may give take Calpol whenever there is a fever. So instead of buying 10, I will go to the pharmacy and then I say I want only three tablets, especially if the tablet is expensive. In India, they don't dispense only with the strip. They give even cut pieces. So when I take a particular, if it is a full strip, I know that what is the name, expiry, and so on. But if it is going to be only one cut piece, and then after the next time when I take, I may not know what is the name of the tablet. So normally we remember what is the color of it and so on, if we take it immediately. But after a week or 10 days, again, if a fever comes, if the doctor says you can take whatever medicine I have given last time, so then you want to know what medicine was, what was the color and so on. We cannot recollect it. But then the built system, again, you can keep the tablet inside and then switch on the lights and camera, and then it is going to tell what is the name of the tablet. Again, not only that, if the doctor has prescribed how frequently we need to take, what kind of precautions you need to take, and when you need to take, whichever language he has given, we have also recorded it and played it. And so it is a kind of a system where whatever medicine which has been written by the doctor is what is dispensed to the patient. And then the patient also, when he is collecting the medicine, he is hearing the instruction for using the medicine once again in the voice of a doctor. The other is, the face recognition system. And of course, we have also done some work in the face recognition system. And here, especially when you want to monitor the people, right, who is there inside, whether only doctor or nurses or somebody else is there. So I want to, use the ICU, I can use it. And we can also, again, use it for eye tracking. Again, there are a lot of medical applications. We are currently working on tracking our eyes. Using this tracking of eyes from a mere video, I can also diagnose a lot of diseases. And then we can also use emotion detection. So using a simple camera, we can detect what is, there are 7 standard emotions which can be easily diagnosed. So a lot of psychiatrist doctors, they are in need of diagnosing these patients. Thanks to COVID, now we want to take only a remote video. From there I want to diagnose what kind of like a depression or stress level the patient is and so on, right? So I may stop here, maybe want of time. If there are questions, I would like to take up. Hello.
Sure, sir.
Yeah.
Thank you for full, sir. And
Okay.
also it was like a very from the basic level you explained us like what are the kind of data available like text data, images, and also like and also only after learning how natural language processing is happening, we really understand that how human minds actually process all these things. Because when a doctor writes a prescription, actually no one understands, even the patients from everyone, no one understands what is written in the prescription, but the pharmacist will exactly identify what he has written. So this is the exact difficulty that is happening
Okay.
with the natural language processing, image, and all those techniques. And also you have explained various techniques like parsing, stemming, text segmentation, and all those things.
Okay.
Also, sir,
Uh-huh.
I understood a lot of things. So,
Mhm.
is artificial intelligence is medicine? Is it really necessary? Like, if so,
Uh,
why?
Yeah, it's a very good question. The number one is, there are emergency situation. For example, if there is an accident and then, somebody is, bleeding, and then if you take, some, let's say some, images or scanning, and then if you are asking for an expert, if the expert is not available, especially we've come to know that there are a lot of radiologists in Bangalore. They have started this, decoding the image data, and then predicting what kind of immediate what we call treatment should be given. So especially people in abroad, they work only 8 hours. So when they don't have an expertise, so the nurses are clueless, what to do and so on. So many a time it is going to be even life saving. So it's of course uh, I think that the time has to tell whether it is necessary or not.
Yes, sir. I do recall that during my internship period in the emergency medicine department, when people comes with, we have to differentiate between hemorrhagic stroke and ischemic stroke. Almost all of the emergency medicine people who are working in the department, they are always well trained. But
Mhm.
still,
Mhm.
after immediately taking CT, we go to the radiologist, we confirm our diagnosis, and then we start the treatment. Because with the alternate diagnosis, the treatment completely differs, and it is completely fatal to the life of the patient if we give the other kind of treatment. So even though we are sure, we are uh, always looking at the opinion of the radiologist at those circumstances. So since we are working in a tertiary care hospital, the radiologist is available 24 by 7. But in some other hospitals where the radiologist works for only 8 hours, and if a patient comes in the emergency medicine department, and we have to look for whether there is any fracture in the cervical spine to decide on the further treatment. We can't be calling, we can't be sending them all those photos in WhatsApp and then asking them. So all those things will be difficult. So yeah, definitely I agree with that, sir.
Okay.
So what is the status of artificial intelligence in medicine? Like what are the hospitals it is in practice? Like what are the steps it has reached so far? And how long it will take to come into real existence in almost all the places in medicine?
Uh, Sir, again, the
Current
as
status
of
of
now,
artificial intelligence in medicine.
yeah, as of now, as I told, even for about 150 medicine, I can tell you the difficult challenge is because even if we take identifying a medicine and then say whether it is a right medicine or not, time and again, even the pharmacy wala is also changing the label, right? Or maybe the shape of the bottle or even the color of the bottle for branding and so on. So once again, you have to acquire the data and then you need to train. It may be even a small change in the font or maybe shape or size or color. So we need to do lot of training again. We have to acquire the images with a different lighting condition from different angle, and then you need to tell it is the same medicine which was given before and so on. So typically the biggest problem we are going to face is the training of a data. Huge amount of data need to be trained, and then whenever there is even a small change, maybe a doctor or a human being can immediately recognize it. As you rightly said, a computer cannot do it, so it has to be trained. But the way the computing that is available, I think things are going to improve. Especially people are now talking of robotic surgery, wherein just like when laser etc came in the beginning, it was not taking up in a big way, but the way the cost of the hardware is becoming cheaper nowadays, I think another 5 to 10 years and so on, in many of these our Indian hospitals also we can see the AI based system. But then it may come, one by one, as you were rightly telling, depending on the context or need, where there is shortage of people, it may come in. Yes.
Yes, sir. I do recall one of the even during my internship orientation program where they were teaching us about how to write a prescription because we have a certain format of how to write a prescription. All the prescription letters should be written in letters. They also quoted one example that a patient, a small 1-year-old child, has come from Kolkata all the way from Kolkata to Vellore to get the treatment, and intern who has written the prescription, he has given some drug that is like some drug which is acting in the gastrointestinal system, but because his handwriting is illegible, the pharmacist has given some other drug. Since the patient is also from Kolkata, he has reviewed only after 3 months, and ultimately it turned out to be an anti-cancer drug. And the child came after 3 months with all the hair has fallen. He has hair loss, and the child has become emaciated, and he has ulcers all over the body. So all these complications happen. So even with the humans, all these errors are happening when the natural language processing is not done in the right way. So maximum errors are possible. And also, as you said, the lot of data we need to analyze all these things, a lot of data we have to feed into the computer. So currently, are there any hospitals using all these technologies, sir? So far I have known, like you quoted one example, like instead of we can use chatbots to whether the drug is available in the pharmacy or not. In CMC, we used to give e-prescription. In drug itself, we know, like there are like about like 4 or 5 pharmacies within that campus itself, and we will know in which campus the stock is available, or else it is not available in any other pharmacies. Those things we already know. So any other hospital similar kind of setup for
actually,
even more advanced things like
as we are very close to
radiological.
We have been working with wellness group, and in fact I have few slides with Dr. George. We have been working, and there, this is the ongoing work which we are doing it, where we want to use for wellness. As you rightly said, we don't want to use AI for making decisions, but we want to use it as a kind of a recommendation system. So even if a doctor, he is like in a cat in a wall, he is for sure what is that, like in a ECG, right? When you see the ECG, if you are a doctor, who is well versed, without even reading it, you will tell what it is. But then sometime you want to read it also, you want to know what it is, and so on. So same way, we want to use or introduce this as a kind of a recommendation system. The problem we are facing is, we are not getting the medical data, right? So the biggest problem is because of, confidentiality and so on. In image data, we can do wonderful things. People are, even in Google is doing, a lot of, AI for diagnosis. But how good these diagnosis? Generally, I'm saying that it may be 80% or 90%, definitely not 100%. So over a period of time with a huge amount of data, it may increase. But then it is not going to replace a doctor, but it is going to assist a doctor. So I would say it is going to be more of an assistive technology rather than a replacement technology.
When I also say about artificial intelligence, it is going to drastically reduce the work of the doctors. Many of them ask the questions like whether it is going to replace the doctor, but definitely it is no, because like even in a pathological study, we have to, for a diagnosis of tuberculosis also, we have to look thousands, hundreds of slides before giving the diagnosis. So if a person, for a single diagnosis, we have to look at 100 slide images. So if we have to continuously, if a person has look at 100 slides for 100 patients, it accounts to about like 10,000 views per day. So if a person is continuously looking at such a way, so it's going to cause him a lot of burnout. So in all these things, AI can assist, and it is not definitely going to lead it. And especially in countries like India, where the manpower is very much low, artificial intelligence is going to do a great job. So you have told that there is lack of data, like confidential issues, ethical issues, and all those things. What is the exact reason why we are not getting data? Whether it is because of cost efficiency, or whether it is because of ethical issues, or whether people doesn't have the awareness about also.
Yeah, it's a good question, sir. So typically I went into, I don't want to name of the scan center, and they were afraid, like what you said, if I give all this data and then if he is able to predict what it is, people may not come to me and so on. So I think, unless we work with the doctors and engineers together, we cannot, solve the problem. Of course, the ethical issues are also there, but many a time we say you can mark the data and give it instead of, telling the name of a patient, you give like XXX, YYY, and so on. So often we are facing the problem of getting a real data. So thanks to the doctor with whom we worked, he is a pediatrician. He gave all the 150 medicine and then gave all his prescription. He has given around 1,000 prescription which he has not written. But if I go to many of these doctors, they are very afraid. Why I need to give this prescription to you? What are you going to do? Are you going to do something else also? They were worried. Because once if I digitize this, they were a little worried, what I'm going to do. So I think, the confidence between the doctors and the researchers should happen.
So it seems that it has become time that doctors should realize that we should advance into all these technologies also. So, okay, sir. So how about the cost effectiveness? How much does it cost? So do we have all those infrastructures?
Yes,
or
sir.
is it because of the lack of
actually,
funding,
what happened?
We are lacking in.
Yeah. Sorry. See, because the video I'm not able to play, the hardware which you have built, it is not going to cost you more than 20,000 rupees. So from scratch, from the readily available components we have built, we have identified what kind of light, how big should be, where it should be, what kind of camera, what kind of motor, what kind of software. Everything we did it from scratch and so on. So I don't think the only difficulty we are going to face is that the data which you have collected for your artificial intelligence to extract the features and to run, it is going to take maybe sometime weeks of time. So we need to have an uninterrupted power supply and so on. I don't think that it is going to be a future. When we tried with 150 medicine, it took about a month for us to solve and then exactly find all medicine. But if I go to a pharmacy or if I come to CMC, you may have 40,000-50,000 medicine. Unless I have a very big computer where I can feed, if I want the model should be built, let us say in 1 hour, then I may need a huge computing infrastructure. But then if we say no problem, sir, you can give after 1 month, I can even run it in a reasonably fast hardware which is costing few lakhs, then I can get even the model. So it's absolutely not an issue. But the only thing is you need to have uninterrupted power supply. The system should be running maybe 24/7 for a week or 10 days and so on. So with
so how about the return of hospital investing in all these infrastructures?
No, it's going to be phenomenal, sir. As I said, when I talk to the pediatrician, he is very busy in Vellore or in Chittoor bus stand. He is nearby, and he is taking about 200 patients per day. Now imagine if a pharmacy is giving an alternative medicine which is not prescribed. He is once again coming and standing in the queue, and then until the next patient comes, he goes inside, and then the waiting patients are getting irritated. And sometimes, I came to know when I was sitting there, many they were not coming to the pharmacy because it is taking more time and so on. So for your information, despite being in in VIT and nearby Vellore to CMC, I don't want to come to CMC. I always feel that they make us to run around. I have to wait in a queue and so on. This is the kind of perception what the common public has got. So rather they go to maybe some other hospital. The only reason is they want less time to be spent in the hospital. Typically you may know that many people are sick of going to the hospital or meeting in a place where there are a lot of patients or there. It is a psychological effect. So when they want to spend less time and then you want to deliver more service, I think definitely you need to go for this AI. Maybe not immediately, as you said, for writing a medicine automatically and so on. But wherever if you are doing this kind of an automation, it is going to make a lot of attraction to the hospitals.
Okay, sir, you have told that the AI is very important and we have to immediately shift. But also there are various kinds of hospitals, from primary hospital, secondary hospital to tertiary hospital. So in as you said, a pediatrician he might have only a single room without even pharmacy attached also.
Correct.
In India also we have very things like we have scan centers separately, X-rays alone, we have pathological labs separately, we have test banks separately, we have micro labs separately, so we have all this separately. So it works in a collaborative way. Only in a tertiary care hospital, in a multi-specialty center, we have almost all these things integrated together. So they have the infrastructure, they have money and all those things. So how about the for a individual person, for a secondary care center, for a primary care center. So how they can integrate in their system, and is it really effective, useful, or it can be done only at higher levels like tertiary care hospital. Like artificial intelligence should be brought into all these setups, or how? What is your suggestion, sir?
No, we can bring it in, sir. Only the issue we are going to face in AI is this customization, right? How big or how small, what data need to be integrated, and so on. Now, thanks to the cloud, what happens is the moment you scan any image, and then if you run your AI algorithm running in a cloud, and then if you bring it back, so through your software, again, we need to stitch them together. So it need not be a big hospital or even small hospital. But then if I give you a solution as a kind of an API or running it in a server or cloud, so I can push my data, then within a few minutes, you may be getting the results out of it. So that you need not always have a dedicated facility. If it is a bigger hospital where more people are going, you can use a dedicated facility. But then if you have a tertiary hospital, we can use the cloud-based, approach.
Okay, sir, for small hospitals, we have to have an integrated system for a image processing, for a laboratory test investigation, for signal processing, for text processing, right? So
Yeah.
if we don't
So,
have all those things,
but nowadays these are all not very expensive, sir. Because because if you have maybe nowadays laptop or with one computer and so on, like nowadays we even take the picture from WhatsApp and then we send it into the cloud. The cloud can do the analysis and so on. But now the problem is the way you are communicating in WhatsApp and the way you are communicating in Facebook are very different. So the same problem we are facing. If you can make an integrated, the software and application which may be running locally in your system, and then also what should be locally processed and what should be processed at remote, it is possible. A bit of customization is what is required now.
sir, as you said, we
Taking an
texting all.
images is of course we have a dedicated, say for example, I cannot use my mobile phone for taking your x-ray. You need to take an x-ray, but then once if the x-ray is available, I can digitize it and give it to my AI and then tell what kind of predictions it can make and so on. So that part we can come in. We cannot replace the existing devices altogether, but wherever the output of a device comes in the form of an audio signal or maybe an image or a text, I can capture it and send it to a cloud, ask my AI algorithm to predict what it is and recommend few things, which a doctor can subsequently use it.
Sir, as you said, like while we text in WhatsApp, also we text in different ways, but the people on the other end actually understand what we are, even if there is a lot of grammatical errors, even if there is language errors and all those things. In a similar way, we need customization for individual people to analyze all this data. Okay, sir. So,
yeah.
Okay. So we understood that doctors play a significant role in establishing AI in the medical, because even though the technologists understand its significance and they have all the infrastructures and all the knowledge, without the contribution from the, it is never going to become possible, right? So what is the contribution of what they should do for these technological advancements to happen?
No,
so a lot of audience are watching our videos.
Yeah, the most important thing is the doctors should also understand these basic terminology, and they have to work with the the engineers, maybe a hardware engineer or software engineer. And we need to see, as a researcher, what we are afraid of is these the words, like most of them are Latin words and so on. We don't remember them. So for us, if you use in a plain vanilla simple text message, we can easily understand. So the synergy between the doctors and the engineers is what is missing, but with the more interaction and collaboration, I think it will be solved.
So it seems that it seems that we should update ourselves with lot of knowledge. We should read ourselves, and all these things should be integrated soon in the curriculum, I think so, sir.
No,
so,
what I'm saying is, if you know even the basic jargons, as a doctor, you are busy in something else. But if you know what is machine learning, what is deep learning, what is AI, what is NLP, okay, what I can do with this, what I cannot do with this, and then you can identify a right engineer or a researcher. If you give all the input information and then review them, that is more than enough. That's what we did with this doctor nearby. So he gave all the data and he gave his requirement, and then we understood. Then we again show a demo and then we explained. He was happy.
Okay, sir, sure, sir. So now I clearly understood that artificial intelligence is really important for the medical field. So as a medico, if I am interested to learn more about these things, how can I learn about those things? What are the sources? Like, are there any courses available? Are there any like materials available? Are there any books or any organizations? Something like that, sir. If I wish to collaborate, if I wish to further, like how can I integrate my
Sir, actually, this is a very wide field now. What we are doing is we are reading a lot of material from the internet, and then there are standard journals like IEEE. We say if you are engineers, there is something called IEEE transactions on medical imaging, etc. Are there? We look at some standard journals and what kind of research, what kind of data they are using, and so on. On the other side, also we visit a lot of blogs. What are the new algorithms are happening and where they are applying and so on. And then when people in some other domain, we are trying to use it for medical imaging, and then we want to see how it is working and so on.
Yes, sir. So if I'm interested, means how can I learn more about that? How can I get the opportunities?
No, we can do a lot of even Googling, sir. We can do a lot of Googling. The textbooks for your information are not many are there, and many of these textbooks are talking more towards writing code or maybe even the mathematics which is involved and so on. So the best way is if you look at some of the blogs which are run by professionals, then you will get more information.
Okay, sir, sure, sir. So we have theoretically described about all these processing. So taking a ECG also, we get an automated diagnosis always. Like
Yes.
it comes printed in the paper, but also still we see that and still we get the opinion to confirm it.
Yes.
So what is the level of the image processing? Can we automate the diagnosis? Is it possible, or what level it is happening at India level? So what is the stage in the current stage in the world level and all those things? So Google, you have also told Google has come, Amazon has come, everyone has come, like lot of research studies to predict this earlier is happening. So even before the human eyes can detect, they are trying to predict those.
Correct.
So what is the current status?
No, actually, in India, we are only at the nascent stage, and there is not much, according to me, collaboration between doctors and researchers is happening. But then wherever they are doing it, the accuracy, as I mentioned, typically it depends on the how much of data you have and what varieties of data we have. For example, if you take even the face recognition system, the lighting that you use, your conventional lighting or etc., are very accurate to recognize who are you. The accuracy is more if you are a black skinned person. If you are a brown skinned person, it is less. If you are a white skinned person, even the accuracy is very less. So it all depends on what kind of even the ethnic issues are there. And so you need to actually you make a lot of customization. So unless this customization, see, if you take a database of the some images which has been captured in the US by the patients in US. For example, they have a lot of skin defect, but when you take in India, thanks to a lot of sun we have, you don't get that much of skin defects you have. So they do a lot of research and then they gather a lot of information and then they analyze and then they concentrate on it and so on. But in a country like in India, we need to see that what kind of disease we are prevailing. There are malaria and so on, which may be prevalent in India, which is very, very rare to see it in countries like in US and Europe and so on. So we people are taking only their data. I know that a lot of our researchers are taking that data and then we are analyzing it. And then probably whatever model I build it and then I test it in your lab, you are not going to get a good result. So we need to closely work with our Indian data, Indian doctor and Indian researcher. That's where we can improve our accuracy. Currently, people are using the data which is available in abroad, but then they want to try it for an Indian patient where the accuracy is also not good. So if you ask me the accuracy, if you have a good amount of data, accuracy can be around 80%. But when you add more and more data like variety, what Google and so on, they may be getting around something around 90 plus also.
So, sir, so currently in India, we are using the open data to test our system, whether it is actually possible or not. So only the testing is done, we are actually going to people to the data, but but we are not getting the data is what you are saying, right?
Yes, yes, sir. Yes, you are right. You are right.
Okay, so like it will take around like next 20 years for India to
No, I
get
don't think, sir. It may take in another 5 years to 10 years. So once if we start, creating our own data set and then, work with that, we may able to catch up quickly.
Okay, sure, sir. So what are the ethical issues that are involved, sir? Because many people are saying it is not ethical and all these technologies should not come into medical practice, especially is what they are
No,
saying.
I don't think
Intelligence can come into other things, but they are saying in medicine it is like unethical.
No, actually, when you take all these COVID, when you take biochemistry, you have the issues. But then, reading a image or a signal or a text and then understanding what it is. And then as long as I say it is only a recommendation system, it is not a decision-making system, I don't think you have an ethical issue. But then when you share the data of a particular patient, that is the only place where we have an ethical issue. Other thing, when you use only, biochemistry based approaches, you have ethical. But then the
Yes,
AI
sir.
use here, I don't think much of an issue.
Yes, sir. Also in cloud security and all those things, they are speaking about the if all those data is stored in a cloud or something else, they are asking about the security, how much the data will be secure.
No, those things are, the part of, your computer algorithms are. Nowadays, we have powerful security algorithms are there. So if you have a proper, security analyst, and then if the company promises that, I don't think much issue will be there. When they don't secure your data and store for, for cost cutting, then we may land up into the problem. Otherwise, I think it will not be a problem.
Okay, sir. Really, thank you for answering all our questions very patiently, sir. And
Thank you, sir.
that's all. All our viewers have these are the questions which our audience had. So
Okay,
thank
sir.
you, sir.
Thank you. Thank you.
So all the audience who are watching this video, if you wish to connect with our speaker, his social media link will be provided in the description and you can connect with him. Also, if you have any suggestions regarding the next topics, regarding the webinars and regarding the way in which should be conducted, you can always you can always text us and we will be taking the necessary action. So see you in one another useful video. Until then, it's Aravind signing off. Bye. Thank you, sir. Thank you for joining us.
Thank you. Thank you. Thank you. Bye.